right. All right, we're gonna get started now. Thanks everyone for coming to our seminar on hurricanes and extreme weather in a changing climate. It's the first of our Global Change seminar series that we'll be presenting during the school year. We got 6 overall, so if you like what you hear here, come back next month and you can hear even more good stuff then. My name is Rachel Sussman. I'll be moderating this today. I'm a first-year master's student in the Marine, Earth, and Atmospheric Sciences Department. I'm one of the Global Change Fellows that is hosting the seminars that's sponsored by the Southeast Climate Adaptation Science Center, which is here on NC State's campus right down the hall over there. So for the seminar today, we're going to be doing a series of lightning talks. Each talk is going to be 5 minutes in length. We got 6 presenters. They all come from a variety of backgrounds and departments, so we should get lots of interesting perspectives on hurricane research that's happening around here. It's going to be a hard cutoff at the 5 minutes. We're going to have actually the NOAA hurricane alarm sound go off, so you'll know when it's done. Presenters will know when it's done. It's kind of alarming, so we're going to do a test run first so you guys know what you're looking for. Prepare yourselves a little bit. So it's going to sound like this. All right, that wasn't as bad as I was expecting. But yeah, at that point when you hear that, that presentation is done. I'll have a quick break as we switch over to the next presenter, and then we'll keep going from there. We're not going to take questions in between speakers. We'll have about 15 minutes at the end of the seminar where we'll have all our speakers come up and have a question panel, and you'll be able to ask any of your questions then. So I think that's just about it. So let's get started. First speaker today is going to be Olivia Vila. She's in the Parks, Recreation, and Tourism Management Department.
Okay, before I get started talking about this research, I want to provide some context. Back in 2016, after Hurricane Matthew, my advisor, Dr. Bethany Cutts, started Project Bridge, building resilience and innovation through diverse group engagement. Funded by North Carolina Sea Grant, it was a project centered around exploring the recovery experiences of Robeson County, North Carolina after Hurricane Matthew. From this engagement, one of the things that emerged was that the community had some concerns about the environmental risks associated with waste from hog and poultry farms making its way into residential areas as a result of hurricane-induced flooding. Separately, there were also concerns about sewage making its way into people's properties after flooding associated with Hurricane Matthew. Fast forward to last year, after Hurricane Florence, we decided to apply for a quick response grant from the Natural Hazards Center to fund supplies that would allow us to add soil testing to Project Bridge. Specifically, we wanted to address the concerns associated with the less visible risks associated with hurricanes and flooding. So those things that are more difficult to see with the naked eye. And consistent with Project Bridge, which again is building resilience and innovation through diverse group engagement, we wanted to make sure we approached soil testing post-disaster in an innovative way that fostered community engagement and built community capacity. To do this, we took a citizen science approach and to explore and discuss risk with the community. So the questions we asked for this project were, what is the distribution of E. coli after a hurricane in Lumberton, North Carolina? And how do disaster survivors, how does engaging disaster survivors in a citizen science protocol facilitate discussion and deliberation about these less visible environmental risks? So now I'm going to talk a little bit about the methods, and I might be going a little fast because I didn't switch it, but for our study site, we focused in on Lumberton, North Carolina, which is within Robeson County. We had limited supplies for this project, so it was important both logistically and to make sure that the results we got were more focused and meaningful. So as I mentioned, we did a citizen science protocol, and I'll walk you through what that looked like in the field. So we would show up to the residents' home and ask them what areas in their home flooded, that they would be in their yard flooded, and that they would be interested in testing for E. coli. Once a spot was identified, we trained the residents to collect their soil according to an E. coli sampling protocol. Then they would collect their soil according to that protocol, and that was the sample that we used for analysis. So along with that sampling, we also took this opportunity to engage the residents in an interview and to ask about their hurricane and flooding experiences, and also about their post-hurricane environmental risk concerns and perceptions. And then we also did, the way we analyzed, we did the lab analysis in an environmental lab here on campus, and the qualitative analysis for the interviews. So with respect to the results, we did find E. coli presence, but unfortunately, by the time we were able to mobilize a team to collect the soil and to get that project going, we could no longer attribute the results, the E. coli results, to Hurricane Florence. But despite this, the results were still important for establishing a baseline from which to compare future testing. So with regard to the qualitative results, these were kind of the themes that emerged. First, the disasters both mask and unmask certain risks. Two, there's certain that the risks you can see with your eyes, for example, mold, were discussed in more detail and with more certainty, and often that meant that people worked to reduce those risks. Three, even though people could physically see certain risks, they sometimes had suspicions about risks, but these were often discussed more generally with less confidence. And it was often, they talked about having didn't have enough proof or didn't have proof to show these risks. And finally, that citizen science was an effective tool for prompting discussions about environmental risk. So in relation to future research, these are some things that we're either currently doing or would like to be doing. And one is extending the project to the whole county. We've already started doing that. We also want to place an emphasis on higher risk populations, so populations that come into contact with soil more frequently, and also populations that can are more likely to get sick from E. coli exposure. And finally, what I find most exciting about this project and this research is that we're helping build the capacity of a community to actually engage in quick response research. If and when there's a future hurricane in this area, we now have a network of trained citizens who are not only interested in their soil risk, but who also have baseline pre-hurricane E. coli data. So this means that the community is becoming better equipped to assess a risk that in the past has just been framed as a suspicion.
All right, strong start. Nailed the timing, pretty much. All right, up next we have Dr. Mike Yoder, who is a remote agent for NC State. He's in that slide.
I just want to know where you got that picture. So my name is Mike Yoder. I'm Associate Director of Cooperative Extension. And my role is to actually help other people be successful in times of disaster. I serve as coordinator of their emergency management program. And for those of you who aren't familiar with Cooperative Extension, it's a federal, state, and local government collaboration. Our responsibility essentially is to take the latest research and package it in ways in which North Carolina citizens can enhance their lives, their livelihoods, and their profitability. Our areas of focus, first is agriculture, second is food and nutrition, and third is youth development. And we have a myriad of specialists on this campus who focus and have expertise in each of those different areas. We also have offices in all 100 counties and the Eastern Band of the Cherokee Indians, and that allows us to get information out to the citizens as quickly as possible, especially in times of disaster. My responsibilities, first and foremost, I'm responsible for making sure that our 750 personnel have the training that they need to prepare for, respond to, recover from, and help mitigate future disasters. Secondly, I'm responsible for communication, not wholly, because we have a great communications team in the college. I work closely with them to make sure that we're getting the right and most appropriate messages to our people, so the internal communication, but also to the external audience, which often means many of the different media outlets as well. Third, I work in support of the many partners that we have in cooperative extension. So whether it's the Department of Agriculture, Farm Bureau, any of the many commodity groups that we have, or it may be with other colleges here in the university or with other universities. I do want to tell you that as part of that role, I have the opportunity to sit in the State Emergency Operations Center during these hurricanes and any other disasters that we might have. And that's been a real education and a real opportunity for cooperative extension. But I want to tell you very quickly about an incident that happened during Hurricane Matthew, and I want you to just think about this a little bit. Robeson County Hospital called in and said they had lost their main source of power. Then they called in about 15 minutes later and said they'd lost their backup power and that they were hand ventilating 16 patients and would have to do that for likely at least an hour, if not more, before they could move those individuals to a different facility, if they were even able to do that. When you stop and think about that, and that brought the entire Emergency Operations Center essentially to dead silence, because we hadn't had to deal with something quite that serious before. But it shows you the kinds of decisions that I don't make the hard decisions around that, but it shows you the decisions that people around us are making in those types of situations. The next thing I do is make sure that we get that information to our administrators so that they can make decisions that can help the organization be successful, and more importantly, keep our people safe and help others as well. The last thing that I do is put together something called News and Notes. And what it is a situational awareness report that is collected by the Extension Disaster Education Network, or EDEN. EDEN is a collaboration of all of the land-grant universities across the country. And each of those universities has someone who focuses in some form of disaster preparedness or response. And so it's nice to have that resource at your fingertips when we can call in experts from other universities. But this situational awareness report goes to EDEN, and then EDEN sends it to the United States Department of Agriculture. Every single day we're working a disaster. That helps USDA determine what resources, if any, they need to mobilize to help states be successful in the recovery. The last thing I do is I go to opportunities like this to tell people what I do. And now you know. Thank you.
All right. Up next, we got Caitlin Simmons. She's in the Marine, Earth, and Atmospheric Sciences Department.
So soundscape ecology encompasses the interaction of sounds from several sources. The first would be biological sound sources from fish vocalizing, as well as abiotic sources such as heavy wind and rain, or even anthropogenic noise from boat noise or oil exploration. Together, these encompass the soundscape. We're able to use underwater soundscapes to understand ecosystem health versus when it gets there. We can figure out who's making the sound, when they're making the sound, and where they're making the sound on the reef. Scientists have used this to estimate ecosystem health. For example, coral reef ecosystems are characterized to have highly diverse, highly abundant marine diversity of life, such that relatively high densities of sniffer species or sound-producing species may indicate reef ecosystem health. So the soundscape is generally characterized by temporal trends, as well as frequency ranges and sound pressure levels or loudness measured in decibels. So you can look at the high band frequency range, which is dictated by snapping shrimp, so here in the coral, or as your fish vocalizations that occupy the low frequency band. So sound pressure levels for the high frequency band often demonstrate a temporal trend and increasing sound pressure levels at crepuscular hours, while reef fish vocalize on daily patterns with the loudest sound pressure levels occurring during the daytime. So we're able to get a baseline for what a normal coral reef soundscape would look like in relation to a natural disturbance. Given the direct impact of Hurricane Irma on the Florida Keys marine soundscape, I'm able to use it before, during, and impact approach to understand how the sound pressure levels and patterns may change after a natural disturbance. For example, through tagging studies, we've been able to see that marine and estuarine teleosts generally leave a habitat when the barometric pressure has dropped. And so in September 10, 2017, Hurricane Irma made its passage across the Florida Keys, and to the left I have examples of my underwater hydrophones that were collecting data on the coral reef soundscape. Before the hurricane, we're able to look at a spectrogram here. This is frequency over time with loudness shown in decibels. And so just looking at the before pattern, we're able to see distinct daily patterns in that fish chorusing across the low frequency band, as well as increased sound pressure levels according to lunar phases. So there's a normal daily pattern of fish chorusing, as well as some lunar periodicity that may be indicative of a healthy habitat where species are spawning around the full moon. So we're going to look at changes from temporal trends before and during and after the soundscape. During the hurricane, Hurricane Irma was actually strong enough. We estimated the acoustic energy exposure to be equivalent to a cruise ship circling the hydrophone for relatively 2 weeks. And shown in this power spectral density plot, we have Hurricane Irma as shown as the dashed line, and you can see that it encompassed a broad range of frequency ranges. And this is the result of acoustic masking from heavy wind and wave action. And in comparing the solid color line to the black solid line before and after, we're able to see that the sound composition also changed after Irma and was relatively quieter after the hurricane. We also took a look at the average mean daytime and nighttime sound pressure levels across certain frequency ranges that relate to fish families. So for the diurnal patterns for fish families, there relatively was no change in sound pressure level, but there was a change for sound pressure levels that for fish species occupying 1200 to 1800 hertz. And these are our cryptic or nocturnal species. There also was a change in the high band that increased in nighttime sound pressure levels as well after Irma. So overall, the change was an increase in nighttime sound pressure levels for certain frequency ranges. We know that Hurricane Irma actually impacted the water quality, so this might be an indication of what actually is taking place to cause these changes in sound pressure level. This NOAA sanctuary image is depicting sand in that light blue color. So if you look at the top panel, that's before Irma. The bottom panel is after Irma, and you can see that there was a high sediment transport and suspension. And so as we look at snapping shrimp, we often wonder if they were trying to restabilize or clear out their burrows after sediment has been pushed into their crevices. Additionally, there was a high impact of reef structural damage on the reef, such as reef ledges dropping, coral sedimentation and fragmentation, as well as there was fast-moving debris on the reef as well. And so we know that these impacts can have a direct or indirect impacts on fish mortality, species distribution, and behavioral changes. Okay, so temporal changes can often show changes in species distribution and their behavior over time. Why am I going so fast? Sorry. We also can see how these temporal changes might affect spawning aggregation, since we have a baseline where we know that they're going to be coursing between the full moon and new moon. We can also see how these sound pressure level changes after the hurricane. So we know that there's a relationship between the soundscape and the seascape. Also, the impact of turbid waters as crevice dwellers try to clear out their burrows and increase in loudness, as well as the change in soundscape composition as species leave and come back to the reef. So in the face of climate change, I hope that we can use non-invasive approaches to understand what's going on during a hurricane, and then also monitor trends in recovery.
All right, we have Dr. Ananda Iyer up next, also Marine, Earth, and Atmospheric Sciences.
Thank you. Right. So this presentation is about acceleration of hurricanes. And so the overarching result that I'm going to convey to you is that hurricanes are decelerating while they're interacting with extratropical weather systems. And this came out of a class project that was done by Anthony Charlanis. So the first thing I'd like to convey to you is that a recent study published last year, Jim Cosin, who's a NOAA scientist, concluded that hurricanes are slowing down, and approximately a 10% slowdown compared to their speeds in about 1949. So that number is about global speeds of hurricanes. And just to give you a quick idea of what makes a hurricane move, we were talking about the forward motion, not the intensity, not the swirling wind, the forward motion. A hurricane to a first order can be thought of a vortex embedded in a large scale flow. So if the flow is changing, the hurricane's motion is going to change as well. So we know that there's evidence that the global circulation has been responding to a warming planet, primarily the reduction of the equator to pole temperature gradient. And so Kelson's work showed that potentially the slowdown of hurricanes is related to the slowdown of the global circulation, which is in response to the temperature changes. So now that was important because a slower hurricane and a moister atmosphere means more floods. Now our interest is in hurricane acceleration. And this particular chart here shows a composite weather map made out of hundreds of cases. And what you're looking at in the lines is an upper level, you can think of the pressure chart. And you're looking at troughs and ridges. The shading shows anomalous pressure. So this is what happens when a hurricane is rapidly accelerating. And this is what we call extratropical transition, a signal of it. It is important because as a hurricane is accelerating, it is transitioning from a tropical system to an extratropical system, and it can impact weather downstream. You could have cases of intense flooding over Europe due to a hurricane in the Atlantic, or a typhoon recurving and transitioning over the Pacific could have impacts over us. And so what we were interested in knowing is there a change in the acceleration of hurricanes? And what we find, and I'm happy to talk about data sets, is that over, we looked at 1970 onwards because we have a little bit more confidence in the data from that period, given that sort of it's a dawn of the satellite era. And the chart here shows essentially the average acceleration calculated for hurricanes over the Atlantic from 1970 to 2020. And we used a certain threshold. We used a threshold of 6 meters per day acceleration, which is what we determined was a good indication of a hurricane interacting with a weather system from the exotropics. And you can see that there's a decrease in the acceleration over this period, and we determined it to be about 13% reduction in the acceleration. And what does that mean, and how is it important? As first, like Kelson's work, we were able to determine that hurricanes are not only slowing down, but also not accelerating when they are interacting with extratropical systems. And this could potentially mean important changes in the way extratropical weather systems and hurricanes interact. And we have several questions. Is it because the interaction between hurricanes and extratropical systems, are the frequencies changing, or is it again another manifestation of a reduction in the global circulation? There are subtle differences. Kelson's work talked about large-scale circulation, so the average flow, but these extratropic interactions are with weather systems, a little bit more stochastic. And so we have to determine what is the underlying mechanism. And then, of course, it also has implications for what might happen if this trend continues for downstream impacts, for hurricanes in the Atlantic impacting European weather and typhoons impacting us. I think I may be under 5 minutes. Thank you.
Next presenter is Russell Nasrallah from Civil Engineering.
Right, so first off, I'm going to tell you guys a little bit about the coastal engineering team at NC State. We're a big group, but we can generally be broken up into 2 overarching categories. You have the remote sensing and geospatial analysis side, which currently has a big overarching project which involves habitat mapping of the Pea Island National Wildlife Refuge, as well as a long-term monitoring project that's looking at Highway NC-12, which runs along Pea Island and through the entire Outer Banks. We also have the coastal and computational hydraulics team, which focuses more on numerical modeling, specifically of the storm surge model ADCIRC. So they're looking to improve the speed and accuracy of that model. My research falls somewhere in between the two. So I'm looking at coastal highway vulnerability, but I'm trying to use numerical models to do that with, to look at that vulnerability, as opposed to using remote sensing techniques to do that. So let's see. So a little bit about my site, my research site. Right now, we're at Clark Labs, right? But we're going to take a little trip down to the beach in this video that I'm going to show you. Didn't know you were going to go on vacation today. So this is my study site. It's along the Outer Banks of North Carolina, which, if you don't know, are a series of barrier islands. So barrier islands are really unique landforms, geologically speaking, because they serve a really excellent purpose of preventing high storm surge and waves from hitting inner coasts. But they're also really vulnerable to things like sea level rise and increasing frequency of intense storms and hurricanes. So I'm particularly looking at, like I said earlier, the road that runs up along the center of this. And if you look, it's a pretty narrow island. So you can imagine that highway sees a lot of potential impacts from storms that are hitting the area. And I've got some pictures of some hurricanes that made landfall. Dorian just recently, obviously, hit the coast, and then we had Sandy, which had a pretty significant impact. So Hatteras Island, which is where Pea Island is located, it has up to 400,000 monthly visitors. I looked at census data or visitor data for August 2019, and they're visiting the National Seashore, but it also has 44,000 permanent residents. Dare County, where Pea Island is located, they projected that their population jumps by 225,000 during peak months. And when you think about all these people who are visiting and living on the Outer Banks, if there's an extreme storm coming through, they all need to be evacuated. Highway 12 is the only way they can get off the island terrestrially speaking. It's a 2-lane road, you can see it right there. And when we have an extreme storm come through, it can do intense impact to the road. So in that bottom right picture, you can see that's Merlot Beach just above Rodanthe, and that's a breach in the road that has basically isolated that entire island from Rodanthe down to Hatteras Village, which makes it difficult for those people to evacuate if they need to. So the numerical model I use is called XBeach. It inputs in the form of ground surface elevations, and also I feed it in waves and water levels for a particular storm. So it may be Sandy, it may be Dorian. And then the model runs and simulates the erosive impact of the storm as it's attacking the beach. The output is a final elevation that shows all the erosive impacts that may have happened. And you can see over here, I have this image. The green lines there are the transects that I look at. So you're walking from the beach over the dune to the back island. So we're looking at one-dimensional. And the brown dots there are the specific transect we're looking at. So you can see the post-Sandy imagery shows that that we should have significant overwash in that area and significant impact to the highway. And my model, which is predicting that, shows that we're seeing that. So what's the point of all of this? I am hoping that by the end of my master's, I will be able to have a forecast model that automatically runs storms inputs and produces maps like the one you see on the right. So what we're seeing here is each point is a transect that I've run. And if the point is green, that means the dunes provided adequate protection. If they're yellow, that means the dune height has been lowered. And if they're red, that means that we've had complete overwash and potential damage to the road, all right? And what I've done is I've overlaid that prediction with an image of the actual island during Hurricane Sandy. So you can see in most areas, I've done a good job, but in the northern part, there's maybe some overwash that I didn't predict. So I hope to pass this information off to NCDOT and NC Emergency Management so that they can use this to inform decisions that they make about defense structures, sandbags, recovery afterwards, and et cetera.
All right, our last presenter is Dr. Erica Henry from the biology department.
All right, I'm ready. So I didn't set out to study hurricanes. I started working in the Florida Keys almost 8 years ago. And I'm really interested in rare butterflies and their habitats and what we can do to restore habitat for rare butterflies. And this is an illustration of one of the systems that I work in. There's 2 rare butterflies, the Florida leafwing and the Bartram scrub hair streak, that both eat this plant as caterpillars, Pylan croton. And this whole sort of system is really rare in South Florida. It's left in tiny little urban fragments and a few places down in the Keys. This is the habitat and what it looks like. These are really cool pine rockland forests. They grow straight out of the limestone. They are the high elevation ridgetops in South Florida. So they were the first habitat to be developed as development expanded in the area, because you didn't have to drain it. Everything else had to be drained. Everything else in South Florida pretty much is wet. So there's big pieces of pine rockland that are left in the Everglades and a few in the Florida Keys. It's a highly fire-adapted system. It needs to burn all the time to maintain the habitat structure for the endemic species that live there, like the croton and the butterflies. But often, like, this is the landscape that you're trying to burn in. And if you're burning for habitat restoration for rare butterflies, you don't want to be the one who, like, lights the match and the butterflies are extinct. So it's scary. It's hard. Like, you also don't want to burn down people's houses. And the more we don't burn, the more overgrown it gets and the more dangerous it gets. So I was interested for part of my dissertation to look at how different disturbances affect croton population dynamics. Can we use some other method to simulate fire in places where it's just logistically too hard to put fire on the ground, but we have these rare species that we really care about restoring habitat for? So I set up this awesome experiment to look at mechanical understory removal methods and prescribed fire. I focused mostly on host plant demography, so I tagged a whole bunch of plants. And then I woke up on September 10th, 2017, and cried into my phone as I kept refreshing the radar, and Irma just annihilated everything that I knew in the Keys. This is my experiment, like right in the eastern eye wall of the storm. But this also presented an opportunity to really look at how management that we'd done on the ground interacted with this disturbance of a hurricane. To give you an idea of what Irma was like on Big Pine Key, the whole island was overwashed by storm surge. This is a photo of Highway US 1 on the island. And the Weather Service estimated the wind gusts exceeded 160 miles an hour. So that knocked over trees. When I got down there after the storm, I was like, oh, it looks like the whole place is mechanically cleared. Like, maybe that's what we're simulating, not an actual fire. But we got some more money, and I went back and I dug through the pine needles and the rafts of vegetation that had floated around and covered my plots, and I found all of my tagged plants, and I was able to look at what plants had survived the fire and what had happened to the population in this really sort of awesome experimental setup. And what we found is that management actually improved the resilience of the system to this hurricane. So the worst place to be if you were a croton plant was in unmanaged habitat on Big Pine Key. It was a little bit better if you were in a place that had been managed prior to the storm with mechanical clearing. And it was even better to be in the Everglades, which was farther away from the storm, but in a habitat that was managed with fire. But we saw this interaction with previous management increasing the resilience of the system. Unfortunately, Irma was the final straw for Bartram's on Big Pine Key. Lack of fire had led to declines in the host plant, which are mirrored in declines in the butterflies. And we haven't seen any butterflies since the storm. So they're still around in the Everglades. There are luckily other places where this butterfly exists, but I also work on a butterfly called the Miami Blue that was just like 60 miles west. And if the storm had gone over there, there would be no more Miami Blues. So when I think about what I've learned from this work that I've done, it's really that, you know, we need to do that scary management. We need to put that management on the ground, even in the face of these like increased probability of these big storms, because it might prevent extinction.
now we're going to do our panel for questions. So if all the presenters could come up, take a seat up here. I'll take some questions. I know Russell has to leave. You say, yeah? All right, he's skipping class. Very respectable. You guys' priorities right. Yeah.
Sure.
I think all I'll do is, if I have questions, just say them and I'll repeat them louder because I can project solidly. Just make sure everyone can hear them. And yeah, if you can, try and divide the questions between the speakers so everyone kind of gets a chance to address some things that they maybe didn't get a chance to mention. All right, who's got questions? Yes.
I have a question for Russell about the habitat, your modeling and the Island National Wildlife. So how extensible will that modeling be to other locations, besides these, I mean, other islands or?
Yeah, actually, Faith is the one leading that project in particular, but to speak a little bit to it, I think it's looking at long-term monitoring because we have a lot of really excellent data for that area that NCDOT gives to us, and we've been collecting it for like 12 years now, and these are like 6 photos a month, and so Faith is 6 photos a year, thank you, 6 photos a year. So Faith is looking at finding a way to categorize those photos and do the habitat mapping and then potentially project it in the future. So I assume with the geospatial techniques you're using that those will be easily transferable maybe to other areas that are similar.
Actually, I mean, I'm just starting this semester, so still developing all the
But it's been going, the project was headed up by Dr. Lillian Montoya before she just left. So Faith is taking over for that now.
We have a question from online from Byron to Dr. Erica Henry. Were you able to determine whether and or to what extent the hurricane itself served as a disturbance event for the vegetation structure and the croton populations?
I guess, I mean, it was a big event. So on Big Pine, the background mortality rate or population growth rate is like 0.8. So that population is shrinking at a rate of 20% a year in the absence of management and hurricanes. And then after Irma, those same control plots, the population growth rate in the year of the storm was like 0.2. So it was a big reduction in the croton population on the island. And we didn't see a lot of recruitment afterwards, like we do see after other disturbances, like both the mechanical clearing and the prescribed fire. There's usually a flush of, seedlings that emerge from the seed bank, and we didn't see that with the storm.
Now I have a question. Do you think that had anything to do with the salt water being washed in the overwash that might be? And that kept the regrowth.
Yeah, potentially. I mean, the one kind of hole in our understanding of the system and the plant is we don't really know anything about the seed ecology. And so, we don't, but it seems like saltwater does not trigger germination.
I'm sure.
But it did make me think about like the way that debris just like floated around in the storm and was deposited in places. How, like that could be a way that seeds get moved and dispersed, but we don't know anything about that.
Thank you.
Yeah.
Also very
parcel. Well, she's asking how often the parcel of land gets burned in the fire management scheme.
In the Everglades, they really try to target about a 3-year fire return interval, and they have big fire units in the Everglades. Like there's a lot. The number escapes me, but like thousands of acres of pine rocklands there. In the Keys, it's like, it hasn't happened in the 8 years that I've been working down there.
Because there's also like emissions from the perspective. So I was wondering like, what is there any research being done, like what is the best rate, best frequency of burning around, like particularly emissions from fire, and how well burning protect the habitat?
Oh, in terms of like a carbon,
Well, carbon emission.
yeah. So I don't know a ton about this, but I do know that people have looked at like sort of the carbon budget or balance for highly fire adapted systems. And you store more carbon when they're burned more regularly, because although a fire suppressed forest stores carbon in the vegetation, when that burns, it emits way more carbon. Does that make sense? But that's just a paper I read.
Question for Dr. Iyer. When you saw the hurricanes decelerating, can you correlate that with more rainfall? I mean, what tends to hurt urban environments is the heavy rainfall, not as much to the storm surge. Is there more rainfall with storm?
Well, it's a good question. Although we didn't address that, but other papers such as COSIN's work that I referred to specifically addressed that. I don't think even COSIN went into that much of a detail, but offered a potential hypothesis that, well, to go to a bigger picture, the question that hurricane scientists are wondering about is what's going to happen to the amount of rainfall that's going to fall from hurricanes as the planet warms, because the atmosphere can evaporate, can, for lack of a better word, have more water vapor in the atmosphere. I think for every degree increase in temperature, the water vapor content can go up by 7%. And so the hurricanes can then take that water vapor and convert it to water and give you intense rainfall. So the storm motion angle says that if hurricanes slow down, that can have an equally devastating impact, because we know slower hurricanes are going to sit in one place and you're going to have rain over the same area. So people are beginning to look at that. And because our sample size is not very large, well, you can use climate models to answer these kinds of questions.
A follow-up question to that. With the correlation between global temperatures and the hurricane deceleration, what is the projection there? I mean, they obviously can't, they're not going to stop altogether, but is there some sort of point where some derived reaction? I mean, what happens when you get additional warming into the system?
Well, so if, from a very simplistic way, if you think about hurricanes being moved along by the large-scale flow, so as the climate changes, the flow is going to change. So yeah, the limiting factor is what is going to dictate the large-scale flow. And if you completely eliminate the equator to pole temperature, which you can do in a simple model, perhaps you'll end up getting very weak flow. But I don't think that's going to be the situation. So the limiting factor is going to be how the large-scale circulation is going to change.
And is that part of that polar decoupling that we've seen referenced? I mean, is that sort of an example of a breaking point where that flow might, change directions or reverse or do something that we just might not be able to predict?
To be honest, I do not know. I don't work too much on climate change issues. I should be forthright about that. So maybe I should. Maybe other people in the room who I can save might be able to comment on that.
Any takers?
The problem I'll say is I'm all around this. I think some of this polar decoupling stuff has been sort of exaggerated. The biggest effect is at 7% per degree Celsius. And that's huge. And that doesn't require a fancy model. That's built into the physics of the universe.
But it's going to zero, right? They're not going to just stop. So.
In terms of this, 7% is the increase in rate. In terms of slowing down, the thing that Yeah, the thing that would limit a storm from just stopping is if it sits in one place for a long time and uses up all the energy in the underlying ocean. This is back to Lanza's area. And so it can't stay there forever. We have seen storms, and most recently the one in Texas, but even on land, wasn't that strong, stayed there for better part of a week, right? And produced 40 inches of rain over Houston. So that's anecdotal, right? But there is some evidence. We can point to the storms are wetter, and the big thing is they're wetter, but they also seem to be slow.
I think that's the whole point of it. Not only the wetter, but the slower. So it's like a 1-2 punch away.
And then,
So, sort of related to Dr. in the work that you do with the people or that are affected by, are they talking about climate change?
can you repeat that question?
Yeah, the question was with the emergency management team that Dr. Yoda works with, did they talk about climate change in relation to that?
So we have extension specialists who are talking about climate change. And it certainly is brought up in a number of different ways across the entire college. It's not something we dwell on. We leave that to the experts. But we are thinking about, so what happens if? And we really look at that with let's say the farmers that we work with in the eastern part of the state. But I can tell you that if we keep having hurricanes every year, or 3 every 4 years, there won't be a lot of farmers in eastern North Carolina. So those are things we're concerned about.
Mike.
Question for Phelan. You mentioned that there was like less noise following the passage of the hurricane. Is that due to those species being like wiped out, or is it due to migration, or a mixture of both? Because I'm wondering, it's like we're going to have maybe stronger hurricanes. Might be something considered.
Yeah, so a lot of the tagging studies, which I base my approach on, that before, during, and after, show that TLUS will leave and go to deeper water where there's less impact from the surface. And so what we were kind of hinting at is that a lot of that masking, I'm not able to detect a lot of the low band and high frequency band because the hurricane was so loud. And so relatively shortly after that, the impact of the hurricane passing, within like 24 hours, the snapping ship were able to come back, but they came back before the fish actually started chorusing. So just kind of using it as a monitoring tool, I relatively think that these fish left the habitat or left an area where I could detect them with the hydrophone. And then slowly over time, they started repopulating and finding their refuge space.
Yeah.
So I actually had a similar question for you, Linda, actually at a different time scale. I'm wondering, are there can you see, of course, limited how many years, can you see sort of slow, gradual ecosystem recovery from the storm? Is there a long-term response curve, a long-term recovery as well?
Yeah, I guess my goal was to do a long-term response, but it was hard to say how to, I guess, distinguish what is classified as long-term. So my deployment period went from July to October. So and after the hurricane, I don't really know if that's a long-term response. So I kind of stuck it to like a short-term recovery response. And then looking at those temporal trends, you can actually see that loudness did increase further away as you got away from the storm. So to me, that's kind of a temporal recovery response, and looking at the increase of sound pressure level over time. And then we also wanted to see if the behavior of the fish would mimic what was happening prior to the storm, which is why I looked at diurnal patterns to see if they would kind of stick to their activity in daylight hour chorusing or nighttime chorusing for those nocturnal species. So I really think a long-term trend would have to maybe extend out a little bit longer than just 1 month. Yeah.
Yeah, I have a question for Russell. So I'm a climate scientist, but in my private life, I'm also an oyster grower. Now, especially with Florence, a lot of farmers lost basically all of their oysters. But depending on where you were, the storm surge, or I guess like the outflow from like rivers, it just depended on where you were in terms of that. But as far as like storm surge, is there some kind of model that can show you, okay, you should not put your oyster farm here, then maybe like after you go to help out with the farmers, it's like just have like a map. It's like no, this area is not good for that. Like, is there anything like that?
Yeah, so the AdSurge storm surge model that a lot of our team members run, generally the way that I've experienced it is it runs in a forecast mode. So they're providing that information to emergency managers to tell them where flooding will be, but any person can run it. It's open source as far as I know. So you can give it the inputs, just like I do with XBeach. So you can make a completely hypothetical storm. You can make a completely hypothetical track. And you can set up the worst case scenario for your oyster farm and see where the flooding is going to impact your area. Now, I took an entire class to figure out how to do that, but it is possible and it is available to people as a thing you can use. Outside of that, I think I think North Carolina has done flood mapping, but I'm sure you've seen stuff like that before.
Yeah.
And a lot of that uses these similar models.
Yeah, I guess it's just places that are open to farming. There's no real nothing that shows, okay, here shouldn't put a farm anymore because we know that you're going to lose everything.
Yeah.
Nothing like that.
Yeah, definitely. And you could do an ensemble approach where you run a bunch of different storms for your area and see okay, for the 500-year storm, which is meaning less and less with climate change, what is a 500-year storm anymore? But for a 500-year storm, what kind of impacts am I looking at? Okay, this might be a good area because for the most part, it's protected. So there's possibilities there. It's just learning how to run a complex model. As far as already done though, I'm not sure. Yeah.
It's actually someone in my lab, Seth Tierkoff, actually made a habitat suitability model for oyster reefs. You maybe can find it online or the Nature Conservancy website, but it doesn't have impacts from storms or hurricanes. It's mainly just about the habitat itself supporting oyster reefs. Yeah, look for that.
Back.
I just have a comment, not a question, but just to say this was fantastic. Thanks to the organizers and the speakers. It's rare to have such a truly interdisciplinary event. For many of it, very critical.
Yeah, agreed. You guys are doing great. We do still have time for a few more questions.
Yeah, I had a question for Olivia. So you talked a lot about the community benefits of citizen science, engagement and starting discussions. Wondering if you could talk kind of about the flip side of that, the questions that you're interested in addressing and how they might require citizen science, if there's another way to approach it or if you have to do citizen science to address the things that you're most interested in.
I think that me personally as a researcher, I think I'm most interested in those community benefits. So the question about the soil testing, that came out directly from prior engagement. So that wasn't something that I was interested in or my advisor was interested in. And we decided we wanted to go into that community and test it. It's something that instead the community said that they wanted to know more about. And we used kind of our expertise with community engagement and these more social science methods to answer those questions. So yes, there's other ways that you could do this soil testing. It could be infinitely more efficient to just go to all the households, collect the dirt, and then go and give people results. But we kind of think of it, what does that actually do for the community? You're just gonna give them a number that doesn't mean a lot. It's actually engaging the individuals and the residents in learning more about why this might be important and kind of the more scientific that makes them I guess you might increase science literacy, but you also kind of give them a tool for advocacy and you make them feel more confident, which that's how I think change might happen in communities, not necessarily just giving them soil results, for example.
Yes.
A follow-up on that, I guess, is so from the engagement and the higher level of information, and the people in Lumberton about this, has that led to movement towards regulation of wastewater systems? Are things moving as a result?
Yeah, so I guess we're not at that phase yet. So we just kind of got the stuff I presented on. I would say that's kind of a pilot. It was more of a pilot test. Now we just recently got funding this year to expand to all of Robeson County, and we are seeking more funding to do more. And the idea is once we have at least these additional results, that we're going to have like deliberation workshops so we can talk about what the results mean. And as I said in the presentation, the results we have now, we can't attribute it to anything in particular. It's more so just preparing for, not reacting after disaster, but now we're prepared to, when there is a future hurricane, that we can tap into this resource, the community can use this resource and actually test to see if there is a result, if there is an impact from hurricanes and flooding on the like E. coli levels. And another thing we're doing is adding heavy metals because it came out of engagement. Once again, it's something else that they wanted.
I have another question for you. Have you worked with the school districts at all?
We haven't yet, but that's one of the things I said we want to kind of focus in on more vulnerable populations. And that's, we're trying to look at children and children under 5 specifically and play spaces. So daycares and stuff like that, because children a lot of times are playing in dirt more than adults, and there's a lot more health risks associated with children getting impacted by kind of E. coli exposure than maybe with adults.
All right, any last questions? All right, well, I think that's about it. Thanks to the presenters, you guys were great. We really appreciate it. Like I said, this is first of 6 series seminars that we'll be having for the year. So the next one will be in about a month from now. Keep an eye on the Southeast Climate Adaptation Science Center website, and we will also be sending out emails about that, letting you know about the future seminars coming up. Thanks, guys.